Okay, sorry about that. 8-2, part 2. All right. Okay, so an even number can be shown as 2 equal groups or as doubles, okay, which makes sense. We got 2, 4, 6, 8. So if it's going to match up evenly, and we can tell we can do it in 2 separate groups, okay? So this is going to be 4 plus 4, and that's going to equal 8. Here, we have our 4 plus 4, but we have an extra one here, so this is going to be odd, okay? Because it's not going to match up perfectly like that. We're not going to be able to divide into 2 separate sections. So circle all the examples of even numbers. So, okay, if we have 6 and 7, we want to think, is that going to be even or odd? We know if we had 6 plus 6, that would be even. So 6 plus 7, oops, should not. I was circling for odd. 6 plus 7 is going to be odd, so we're not going to circle that as an even number. 8 plus 8. Okay, if we have 8 in one circle and 8 in another circle, is that even? Yes, it is. Okay, 24. Again, we want to look at just the number in the ones place value. So if we have 4 items, can we separate into 2 separate groups and equal groups? Yes, we can. 107, we only have to look at the 7. So if we have 3 and 3, that's 6, plus 1 more is 7, that's going to be odd. So we're not going to circle that one. Okay, an odd number cannot be shown as 2 equal groups. Okay, so here we have a nice equal group, 3 and 3. Here we have 2 and 2, that's equal. This little guy out here is going to offset us, okay? So this one's going to be odd, and this one's going to be even. So circle all the examples of odd numbers. Okay, if we have 2 and 2, that is not going to be odd. Okay, we had our 2 and 2, and now we have a third one. So we have 3 plus 2. That's going to be odd. 28, we're only concerned about the 8. So think about 8. It would be 4 and 4. In each little group, 4 and 4. So that's going to be even. I'm not going to circle that because we're looking for odd. 19, just the 9. Okay, so 9 would mean here's 4 and 4 is 8. 1 more is 9. So does 9 divide up evenly? No, it does not. That would mean it is odd. Okay, when you add even and odd numbers, you can see a pattern. So how many do we have here? Write that down right here. Should be a 4 plus how many? 2. So that's going to give us our 1, 2, 3, 4 plus our 2. So is that's 6, and 6 is an even number, which makes sense. If I have even numbers and even numbers and I put them together, my answer is still going to be even because I don't have any left. I don't have any left over here. I don't have any left over here. If I put them together, I'm still not going to have any left over because they were even to begin with. So as long as they are both even, our sum will be even. Here we have 1, 2, 3, 4, 5. So is that odd or even? Write that right there. Okay, odd number plus 1, 2, 3, 4, 5. Right, if that's even or odd. Okay, has a what sum? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 plus 5 is 10. And is 10 even or odd? It's even. Okay, why is it even? Let me show you. Okay, we have 5, right? Woo! Okay, we got our 5 and 5. These are both odd numbers, right? Because that's our nice, pretty, even set of 4 and our even set of 4, okay? So we have 5 plus 5. Well, look, these are even. They have 1 extra. These are even. They have 1 extra. Look what the 1 extras, when we put this all together to make 10, the 1 extras come together and make a pair. So our answer is even because we had 1 extra left over that made this odd and 1 left over. We match them up when we put it together and they make a pair. which then makes this go back to even, okay? So an odd number plus an odd number actually has an even sum because you have one left over here and one left over here, and we take those and we put them together right there. Okay, here was our 1, 2, 3, 4. 1, 2, 3, 4. Here's our 1, 2, 3, 4. 1, 2, 3, 4. Here's this leftover guy, and here's this leftover guy. We put them together, and all of a sudden, 2 leftovers equals a pair, and we become even. Okay, describe a pattern shown by the sums that are shaded. Explain why the pattern is true. Okay, so if you look at the numbers that are shaded, okay, this is like, remember our multiplication grid where we did like this number times this number and our product was there, except that this is addition. So this number plus this number equals this number. So we have 2 plus 2 equals 4 right there. Okay, so it's the same type of grid that we can use. All right, so let's start with 1. We have 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5. So as we're going across here, we're adding 1 every single time, okay? So if you look at it, this one's odd. If we add 1 more, we become even. If we add 1 more, we become odd. Because here we were even, we had 1 and 1 in each group. Now I'm adding 1 and 2. So now I'm going to have 1 left over. When I add another one, my leftover just got matched up with a pair. Okay, we have 1 plus 1. 1 plus 1 is 2. When I do 1 plus 2, I'm now at 3, and that's odd. When I do 1 plus 3, okay, 1 plus 3, looky here, I have 4. So my leftover came over here and made a pair. Now I have 4, and that's even. When I do 1 plus 4, okay, here's my 4, and I add 1. Now I'm at 5, I'm odd again. Guess what happens when I add another one? I go to 6, now I'm even. So it's going to rotate and flip-flop every time when you're counting by ones like that, okay? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have even, odd, even, odd, even, odd, even, odd, even, odd. Because here you have 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. So every time you're adding 1, you're flip-flopping between even and odd. So describe a pattern shown by the sums that are shaded. I would say every time you add 1, you are going between even and odd. And you just keep going back and forth between even and odd on that. Okay, very good job. See you tomorrow.